Namaste, space cadets and mythology enthusiasts. Welcome to our grand cosmic adventure, where we'll be exploring the universe through the twin lenses of science and Hindu mythology. Buckle up, because we're about to embark on a journey that's as awe-inspiring as it is mind-boggling. You know, humans have always gazed up at the stars, haven't we? It's in our DNA to wonder, to question, to seek answers in the vast cosmic canvas above. From our ancestors huddled around flickering fires, spinning tales of celestial beings, to today's scientists peering through powerful telescopes, our fascination with the cosmos has never dimmed. And why should it? The universe, with its billions of galaxies, trillions of stars, and uncountable planets, is the ultimate mystery box. It's a cosmic playground where the laws of physics dance with the forces of creation, where black holes lurk like cosmic predators, and where stars are born and die in spectacular supernova explosions. So, get ready to dive deep into the cosmic soup with me. We'll be traversing the vast expanse of space and time, exploring the origins of the universe, the birth and death of stars, the formation of galaxies, and the very planet we call home. Now, you might be wondering why we're blending science and mythology. Aren't they like chalk and cheese, you ask? Well, not quite. You see, both science and mythology represent humanity's quest to understand our place in the universe. Science, with its rigorous observations, experiments, and theories, provides us with a framework for understanding the physical world. It's like the blueprint of the cosmos, revealing its intricate workings with astonishing precision. Mythology, on the other hand, is humanity's first attempt to make sense of the world around us. It's through myths that we've tried to explain natural phenomena, grapple with existential questions, and find meaning in the face of the unknown. Think of it like this: science is the brain, and mythology is the heart. Science provides the logical framework, while mythology infuses it with wonder, awe, and a sense of interconnectedness. In this series, we're not here to pit science against mythology. Instead, we'll explore how these two seemingly disparate perspectives complement each other, enriching our understanding of the cosmos. Let's be honest, the universe can be a pretty intimidating place. Black holes, dark matter, quantum entanglement. It's enough to make your head spin faster than a neutron star. But fear not, dear viewers, because we're going to break down these complex concepts into bite-sized pieces that even your pet goldfish could understand, although they might need a bigger tank to grasp the concept of infinity. We'll be using plain English, a dash of humor, and a whole lot of enthusiasm to make this cosmic journey both enlightening and entertaining. Think of it as a crash course in cosmology, but without the boring lectures and sleep-inducing textbooks. So, whether you're a seasoned stargazer or a complete novice, get ready to have your mind blown wide open as we delve into the wonders of the universe. Now, let's talk about mythology, specifically Hindu mythology. Unlike some cultures that viewed the cosmos as a vast, empty space, Hindu cosmology paints a vibrant and dynamic picture of the universe. It's a tapestry woven from intricate stories of gods and goddesses, celestial beings, and cosmic events. These myths weren't just bedtime stories, though. They were our ancestors' way of explaining the unexplainable, connecting with the cosmos on a deeper level. They were a way to make sense of the world around them and find their place within it. Think about it. Before telescopes and supercomputers, all we had were our eyes and our imaginations. And let's be honest, the universe puts on quite a show, doesn't it? The sun rising and setting, the moon waxing and waning, the stars twinkling in the night sky. It's enough to spark anyone's imagination. So, our ancestors created stories to explain these celestial wonders, weaving narratives that connected them to the cosmos and gave meaning to their lives. And these stories, passed down through generations, became the foundation of their beliefs, their rituals, and their understanding of the universe. Vast cosmic ocean, a primordial soup of pure potentiality. This sounds familiar, doesn't it? In this cosmic ocean floated a golden egg, known as Brahmanda, the cosmic egg. Inside this egg slumbered Brahma, the creator god. And what does Brahma do when he wakes up? He bursts forth from the cosmic egg, splitting it open to create the universe. Talk about starting your day with a bang. Shiva's cosmic dance. Now, the universe isn't a static thing, is it? It's constantly moving, evolving, changing. Galaxies collide, stars explode, black holes devour everything in their path. It's a cosmic dance of creation and destruction, a never-ending cycle of birth, death, and rebirth. And who better to embody this cosmic dance than Shiva, the Hindu god of destruction and transformation? You see, Shiva isn't just some angry deity with a penchant for destruction. He's a complex figure who represents the cyclical nature of the universe, the idea that endings are also beginnings. One of the most iconic images in Hindu mythology is that of Nataraja, the cosmic dancer. Shiva is depicted in mid-dance, surrounded by a ring of fire, representing the cycle of creation and destruction. With one hand, he creates the universe, while with the other, he destroys it, reminding us that change is the only constant. It's a powerful metaphor, isn't it? And it's one that resonates deeply with our scientific understanding of the universe. Just like Shiva's dance, the universe is in a constant state of flux, with stars being born and dying, galaxies colliding and merging, and black holes shaping the cosmic landscape. Our journey begins. So, there you have it, folks. We've dipped our toes into the vast cosmic ocean, explored the realms of science and mythology, and glimpsed the intricate dance of creation and destruction that governs our universe. But this is just the beginning of our adventure. In the next sections, we'll delve deeper into the mysteries of the cosmos, exploring the formation of galaxies, the birth and death of stars, the secrets of black holes, and the ongoing quest to understand our place in this grand cosmic tapestry. So, fasten your seatbelts, keep your minds open, and get ready for a mind-blowing journey through the cosmos. Setting the cosmic stage. All right, space cadets, let's rewind the cosmic clock to the very beginning, shall we? I'm talking about a time before time existed, a point so infinitesimally small that it makes a grain of sand look like a giant cosmic beach ball. Now, picture this. There's no space, no matter, not even darkness, because darkness itself is a something. There's just this unimaginable nothingness, a singularity where all the laws of physics take a vacation. It's enough to give even the most seasoned physicists a migraine. But hold on tight, because things are about to get explosive, literally. This singularity, this point of infinite density and temperature, doesn't stay put for long. It's like a cosmic jack-in-the-box, just waiting to burst open. And burst it does, in a mind-boggling event we call the Big Bang. This wasn't your everyday firecracker explosion, though. This was the mother of all explosions, the cosmic eruption that birthed the universe as we know it. The Big Bang, a tiny speck of immensity. The story of our universe begins with an event so monumental, so profound, that it defies the limits of human comprehension. Now, the term Big Bang might conjure images of a massive fireworks display, but it was less of a bang and more of a rapid expansion. Picture a cosmic explosion, not in the sense of a bomb going off, but rather an incredibly swift stretching of space itself. Imagine a balloon being inflated at an unimaginable speed, stretching outwards in all directions simultaneously. This balloon, however, isn't just expanding into empty space, it's creating space as it grows. That's the Big Bang for you, a moment of pure creation, where time and space as we know them began to take shape. In a fraction of a second, a time interval so short it makes a blink of an eye seem like an eternity, the universe went from being smaller than an atom to an expanse billions of light years across. This rapid expansion is known as inflation, and it set the stage for everything that would follow. And it didn't stop there. Oh no, the universe kept expanding, cooling, and evolving into the cosmic wonderland we see today. Over billions of years, matter coalesced to form stars, galaxies, and eventually, the complex structures that make up our universe. Now you might be thinking, hold on, how can something come from nothing? This question has intrigued and baffled minds for generations. And that's a great question, one that has puzzled physicists and philosophers for centuries. The idea that the universe could emerge from a singularity, a point of infinite density and temperature, is as mind-boggling as it is fascinating. The Big Bang theory doesn't explain what caused the singularity or what existed before it. It's a boundary in our understanding, much like the edge of a map marked, "Here be dragons." It's like trying to figure out what's north of the North Pole. It's a question that might not have an answer. The concept of before the Big Bang might not even make sense in the context of our current understanding of time and space. But here's the kicker. We have evidence. The Big Bang theory isn't just some wild guess. It's supported by a mountain of observational evidence, like the cosmic microwave background radiation, which is like the afterglow of the Big Bang. This faint radiation, detected in every direction we look, is a remnant of the early universe, a snapshot of the cosmos when it was just 380,000 years old. It's the faint whisper of creation that still echoes through the universe. This afterglow provides a wealth of information about the early universe, including its temperature, composition, and the seeds of structure that would eventually grow into galaxies and clusters. So, while the Big Bang might remain one of the greatest mysteries of all time, it's also one of the most well-supported theories in cosmology. It reminds us that even from a tiny speck of immensity, the universe can unfold in ways that are both wondrous and awe-inspiring. From soup to substance, the first few moments. In the first few moments after the Big Bang, the universe was a chaotic and scorching hot soup of elementary particles. Quarks, leptons, bosons, the whole gang was there, buzzing around like fireflies on a summer night. These weren't your ordinary particles, mind you. They were the building blocks of everything we see around us today, the very essence of matter itself. As the universe expanded and cooled, these particles began to slow down, like dancers getting tired after a wild night out. And as they slowed down, they started to interact with each other, forming more complex structures. It's like a cosmic game of Lego, with the universe using these fundamental particles to build everything from atoms to galaxies. First came protons and neutrons, the chunky particles that make up the nucleus of an atom. Then came electrons, those tiny negatively charged particles that whiz around the nucleus like planets orbiting a star. And voila! With these ingredients in place, the universe had its first atoms, primarily hydrogen and helium, the lightest and most abundant elements in the cosmos. These atoms, forged in the crucible of the Big Bang, became the seeds for everything that followed. They clumped together under the influence of gravity, forming vast clouds of gas that would eventually give birth to the first stars and galaxies. Echoes of creation. Cosmic microwave background. Now, remember that afterglow I mentioned earlier, the cosmic microwave background radiation? It's one of the most significant discoveries in cosmology. Well, it's not just some faint whisper. It's a treasure trove of information about the early universe. This radiation is a snapshot of the universe when it was just a baby, a mere 380,000 years old. It's like a cosmic baby picture, giving us a glimpse of what the universe looked like when it was just 380,000 years old. At that time, the universe was filled with a hot, dense plasma of protons, electrons, and photons. Think of it this way. Imagine looking at a distant streetlight through a thick fog. The light is scattered and diffused, making it hard to see the source clearly. You can't see the streetlight clearly, but you can see the diffuse glow of its light scattered by the fog. This is similar to how we observe the cosmic microwave background. The cosmic microwave background is similar. It's the faint afterglow of the Big Bang's heat, stretched out over billions of years and reaching us from every direction in the sky. It's the faint afterglow of the Big Bang's heat, stretched out over billions of years and reaching us from every direction in the sky. This radiation has cooled over time, now measuring just a few degrees above absolute zero. And just like that streetlight's glow can tell you something about the fog, the cosmic microwave background radiation tells us a lot about the early universe. It provides a wealth of information about the conditions and composition of the universe at that time. It tells us that the early universe was incredibly hot and dense, just as the Big Bang theory predicts. The temperature was around 3000 Kelvin, and the density was much higher than it is today. It also tells us that the universe was remarkably uniform in its early stages, with only tiny fluctuations in density that would later grow into the stars and galaxies we see today. These fluctuations are the seeds of all the structure in the universe. So, there you have it, folks. The cosmic microwave background radiation is like a time machine, allowing us to peer back into the distant past and witness the echoes of creation. The cosmic microwave background radiation is like a time machine, allowing us to peer back into the distant past and witness the echoes of creation. It's a remarkable tool that helps us understand the origins and evolution of the universe. It's a testament to the power of science and our ability to unravel the mysteries of the universe. Through careful observation and analysis, scientists have been able to decode the information carried by this ancient light, revealing the story of our cosmic origins. The study of the cosmic microwave background has led to numerous breakthroughs in our understanding of the universe. It has confirmed the Big Bang Theory, provided insights into the rate of expansion of the universe, and helped us understand the distribution of matter and energy. Advanced telescopes and instruments, such as the Planck satellite, have allowed us to measure the cosmic microwave background with incredible precision. These measurements have refined our models of the universe and opened up new avenues of research. The cosmic microwave background also provides clues about the mysterious dark matter and dark energy that make up most of the universe. By studying the patterns in the radiation, scientists can infer the properties and distribution of these elusive components. In conclusion, the cosmic microwave background is a window into the past, a relic of the early universe that continues to inform and inspire us. It's a reminder of how far we've come in our quest to understand the cosmos and how much more there is to discover. As we continue to explore the universe, the cosmic microwave background will remain a key piece of the puzzle, guiding us on our journey to uncover the secrets of the cosmos. The adventure of discovery is far from over, and the cosmic microwave background will be our faithful companion along the way. From fire to formation, the universe cools down. So, we've covered the Big Bang, that grand cosmic explosion that started it all. But what happened next? Did the universe just say, "Well, that was fun," and call it a day? Not a chance. The universe, like a teenager with a fresh driver's license, was just getting started. Remember that chaotic soup of particles we talked about? Well, as the universe expanded, it also cooled down, like a cup of chai left out on a winter morning. And as it cooled, these particles started to slow down, like guests at a party after one too many samosas. And just like those party guests, these particles started to get a little close. They began to clump together under the influence of gravity, forming the seeds of larger structures. Think of it like this. Imagine sprinkling flour on a plate of water. The flour particles don't just stay scattered, they clump together, forming little islands. This clumping together of matter was a crucial step in the evolution of the universe. It marked the transition from a homogeneous soup of particles to a universe with structure, a universe where galaxies, stars, planets, and even life could eventually emerge. The Cosmic Dark Ages, a universe in waiting. Now, you might think that with the formation of the first atoms, the universe would be lit up like Diwali. But surprisingly, this period is often referred to as the Cosmic Dark Ages. It's like the universe took a power nap after the excitement of the Big Bang. You see, during this era, which lasted for hundreds of millions of years, the universe was filled primarily with neutral hydrogen gas, which doesn't emit much light. It was dark, it was boring, and frankly, it was a bit of a cosmic downer. But don't worry, things wouldn't stay dark forever. Hidden within this cosmic darkness, gravity was hard at work, pulling matter together, setting the stage for the next act in the universe's grand drama. Imagine a group of friends huddled around a campfire, sharing stories and waiting for the sun to rise. That's kind of what the universe was like during this time. Dark, quiet, but full of anticipation for the light to come. Gravity wasn't done yet. It wasn't content with just creating stars, it wanted to bring them together to create even larger structures. And so, under gravity's guiding hand, these stars began to cluster together, forming galaxies, vast islands of stars, gas, and dust scattered throughout the expanding universe. These early galaxies were like cosmic melting pots, places where stars were born, lived out their lives, and eventually died, seeding the surrounding space with the raw materials for new generations of stars and planets. It was a time of intense star formation, galactic collisions, and the gradual evolution of the universe into the complex and diverse place we observe today. We've talked about the Big Bang, the formation of the first stars, but how did we go from a universe of scattered stars to these magnificent, sprawling structures we call galaxies? Well, as always, gravity takes center stage. Imagine the early universe as a massive cosmic pool table with stars scattered about like billiard balls after a good break. Gravity acts as the invisible cue stick, gently nudging these stars closer together. Over millions of years, these gentle nudges add up, causing stars to clump together in larger and larger groups. These groups, bound by their mutual gravitational attraction, begin to take on a life of their own, swirling and spinning like cosmic dancers. As these groups grow, their gravitational pull intensifies, attracting even more stars and gas clouds from their surroundings. Like a snowball rolling downhill, these proto-galaxies continue to accrete material, growing larger and more massive over time. This process of galactic assembly wasn't a neat and tidy affair. It was a chaotic and dramatic period, with galaxies colliding and merging, tearing each other apart, and then coming together again in new and spectacular forms. Now, not all galaxies are created equal. Just like there's no shortage of personality in a Bollywood film, the universe boasts a dazzling variety of galactic shapes and sizes. It's like a cosmic fashion show out there, with galaxies strutting their stuff in all their glory. First, we have the elegant spiral galaxies, like our very own Milky Way. These galaxies are characterized by their graceful spiral arms, which wind outwards from a central bulge like celestial pinwheels. These arms are hotbeds of star formation, where gas and dust are compressed, igniting new generations of stars. Then there are the elliptical galaxies, the elder statesmen of the cosmos. These galaxies are more rounded, lacking the dramatic spiral arms of their younger counterparts. They're often found in the hearts of galaxy clusters, where they've had billions of years to gobble up smaller galaxies and grow to enormous sizes. And let's not forget about the irregular galaxies, the rebels of the galactic realm. These galaxies defy categorization with their chaotic shapes and unpredictable behavior. They're often the result of galactic collisions or close encounters, their structures twisted and distorted by the gravitational tug-of-war. The diversity of galactic shapes is a testament to the dynamic and ever-evolving nature of the universe. Each galaxy tells a unique story, a cosmic narrative written in the language of stars, gas, and dust. Now, let's zoom in on our own galactic abode, shall we? The Milky Way, a barred spiral galaxy, is our cosmic home sweet home. Imagine a giant disk about 100,000 light-years across, with a central bulge and graceful spiral arms swirling outwards. That's us, folks. Our solar system, with our sun and its 8 planets, resides in one of these spiral arms, about 2/3 of the way out from the center. We're like the family living in the suburbs, far enough from the hustle and bustle of the galactic center, but close enough to enjoy the view. The Milky Way is a bustling metropolis of stars, gas, and dust, home to hundreds of billions of stars, each shining with its own story. And like any good city, it has its fair share of secrets, from supermassive black holes lurking in its heart to mysterious dark matter holding it all together. But the Milky Way isn't just a pretty face. It's a dynamic and evolving place, constantly changing and reshaping itself over cosmic timescales. A galactic recycling plant, the circle of stellar life and death. The universe is a vast and intricate tapestry, woven with the threads of countless stars and galaxies. At the heart of this cosmic masterpiece lies a process both ancient and ongoing, the birth, life, and death of stars. Now, galaxies aren't just static collections of stars. They're dynamic ecosystems where stars are born, live out their lives, and eventually die, only to have their remains recycled to create new generations of stars. This continuous cycle ensures that the universe remains ever-changing and vibrant, a testament to the enduring nature of cosmic evolution. It's like a cosmic version of the circle of life, playing out on a grand, galactic scale. Just as life on Earth follows a cycle of birth, growth, decay, and rebirth, so too do the stars in the heavens above. This celestial dance is a reminder of the interconnectedness of all things, from the smallest atom to the largest galaxy. Stars are born in vast clouds of gas and dust called nebulae, where gravity pulls material together, igniting nuclear fusion in their cores. These stellar nurseries are the cradles of the universe, where the raw materials of space come together to form new stars. The process is both delicate and powerful, a balance of forces that results in the creation of light and heat. These stellar nurseries are scattered throughout the spiral arms of the Milky Way, constantly churning out new stars. Each new star is a beacon of light, a testament to the ongoing process of creation that defines our galaxy. The Milky Way, with its billions of stars, is a dynamic and ever-changing entity, a cosmic factory where new stars are born and old ones die. These stars, depending on their mass, live for millions or billions of years, fusing hydrogen into helium in their cores and radiating light and heat into the surrounding space. The life of a star is a delicate balance of forces, a constant struggle between gravity and nuclear fusion. This balance determines the star's lifespan and its eventual fate. But eventually, their fuel runs out and they die, often in spectacular fashion. The death of a star is a dramatic event, a final burst of energy that can outshine entire galaxies. This process, though violent, is a necessary part of the cosmic cycle, a way for the universe to recycle its materials and create new stars. Some stars, like our Sun, end their lives as white dwarfs, slowly cooling embers of their former selves. These remnants are the final stage in the life of a star, a quiet end to a once brilliant existence. White dwarfs are a reminder of the impermanence of all things, a testament to the ever-changing nature of the universe. Others, more massive stars, go out with a bang, exploding as supernovae, briefly outshining entire galaxies and scattering their enriched remains into space. These explosions are some of the most powerful events in the universe, a final act of creation that spreads the elements forged in the heart of the star throughout the cosmos. These stellar ashes, enriched with heavier elements forged in the hearts of stars, then become the raw materials for new generations of stars and planets. The cycle of stellar life and death ensures that the universe is constantly renewing itself, a never-ending process of creation and destruction. And so the cycle continues, a cosmic dance of creation and destruction, with galaxies acting as both cradles and graveyards for stars. This process is a reminder of the interconnectedness of all things, a testament to the enduring nature of the universe. It's a beautiful and awe-inspiring process, one that reminds us of the interconnectedness of everything in the universe. The circle of stellar life and death is a testament to the enduring nature of the cosmos, a reminder that even in the vastness of space, everything is connected. From dust to disks, the birth of a solar system. All right, cosmic explorers, we've journeyed through the vast expanse of the universe, witnessed the birth and death of stars, and marveled at the grandeur of galaxies. Now, let's zoom in on our own little corner of the cosmos and uncover the fascinating story of our solar system's birth. Picture this. About 4.6 billion years ago, our solar system was just a giant, swirling cloud of gas and dust, a cosmic nursery rhyme waiting to be written. This cloud, called a solar nebula, was a chaotic mix of leftover material from previous generations of stars, like a cosmic recycling bin filled with stellar odds and ends. Now, this nebula wasn't just sitting there, twirling its cosmic thumbs. It was slowly rotating, like a lazy Susan at a cosmic banquet. And as it rotated, gravity, that ever-present cosmic matchmaker, began to draw the material towards the center, like moths to a celestial porchlight. As more and more material piled up in the center, the nebula's rotation sped up, like a figure skater pulling in their arms. The cloud flattened into a spinning disk, with most of the material concentrated in the center, like a cosmic pizza dough being tossed and spun by a celestial chef. Gravity, the master sculptor, shaping the solar system. Now, with the solar nebula spinning like a cosmic carousel, gravity continued to work its magic, shaping the destiny of our solar system. The central region, where most of the mass had gathered, became incredibly dense and hot, like a cosmic pressure cooker on high heat. This central region would eventually become our Sun, but for now, it was a protostar, a baby star just beginning to flex its thermonuclear muscles. As the protostar grew hotter and denser, its gravitational pull intensified, reigning in the surrounding disk of gas and dust. Within this swirling disk, gravity began to sculpt the planets we know and love today. Tiny particles of dust, drawn together by electrostatic forces, began to clump together, like cosmic dust bunnies forming under a celestial couch. It's a wonder anything survived, but survive they did. And over millions of years, these planetesimals gradually coalesced into the planets we know today. But the story doesn't end there. The planets weren't content with just sitting still, like guests at a boring cosmic tea party. They interacted with each other gravitationally, tugging and pulling on each other, shaping their orbits and destinies. Cosmic dance partners, the Moon and other natural satellites. All right, folks, we've explored the formation of planets, those majestic celestial bodies that grace our solar system. But the cosmic story doesn't end there. Orbiting many of these planets are smaller, often overlooked objects, natural satellites, more affectionately known as moons. Now, when we think of moons, our minds naturally gravitate towards our very own lunar companion, the Moon. It hangs in our night sky, a celestial beacon that has captivated humanity for millennia. But the Moon is just one member of a vast and diverse family of natural satellites scattered throughout our solar system. From the colossal Ganymede, Jupiter's largest moon and the biggest in our solar system, to the tiny, potato-shaped Phobos, nervously circling Mars, moons come in all shapes and sizes. Some, like Saturn's Enceladus, harbor vast oceans of liquid water beneath their icy shells, hinting at the possibility of life beyond Earth. These celestial dance partners don't just add to the visual splendor of our solar system. They play a crucial role in shaping the dynamics of their planetary systems. They influence tides, stabilize planetary rotations, and even provide a source of wonder and inspiration for us Earthlings. Now, let's turn our attention to our nearest celestial neighbor, the Moon. This familiar, cratered sphere holds a special place in our collective imagination. It's been a source of myths and legends, a beacon for navigators, and a stepping stone for humanity's first foray into the cosmos. But the Moon is more than just a pretty face in our night sky. It's a celestial time capsule, preserving a record of the early solar system's tumultuous history. Unlike Earth, with its ever-changing surface sculpted by plate tectonics, erosion, and the relentless march of life, the Moon's surface remains largely unchanged, a testament to its ancient origins. By studying the Moon's craters, Maria, those dark, flat plains, and highlands, scientists can piece together the history of our solar system's early bombardment phase, a period when rogue asteroids and comets wreaked havoc on the inner planets. The Moon also holds clues to the formation of our own planet. The leading theory suggests that a Mars-sized object slammed into the early Earth, ejecting a massive amount of debris that eventually coalesced to form the Moon. This giant impact hypothesis, supported by lunar samples brought back by the Apollo missions, highlights the dramatic events that shaped our planet's early history. Now, let's venture beyond the familiar Moon and delve into the realm of asteroids, those cosmic leftovers from the solar system's formation. Imagine a vast cosmic junkyard, filled with rocky remnants from the early days of our solar system. That's the asteroid belt, a region between Mars and Jupiter, where millions of asteroids, ranging in size from pebbles to dwarf planets, orbit the Sun. These asteroids aren't just cosmic debris, they're like time capsules, preserving pristine samples of the material that formed our solar system. Studying their composition provides valuable insights into the conditions and processes that existed during those early days. Now, while most asteroids reside in the asteroid belt, some have more adventurous trajectories, crossing paths with Earth's orbit. Now, before you start panicking about a Hollywood-style asteroid apocalypse, let me assure you that the chances of a large asteroid hitting Earth are astronomically small. But even small asteroids can pack a punch. Remember the Chelyabinsk meteor that exploded over Russia in 2013? That was a relatively small asteroid, about 20 meters across, but its airburst still caused widespread damage. So, while we shouldn't lose sleep over killer asteroids, it's always a good idea to keep an eye on the cosmic neighborhood, just in case. While asteroids are the rocky remnants of the solar system's formation, comets are like cosmic snowballs, icy relics from the outer reaches of our cosmic neighborhood. Imagine a giant, dirty snowball, a mixture of ice, dust, and rock, hurtling towards the Sun from the depths of space. That's a comet, my friends, and they're a sight to behold. As a comet approaches the Sun, its icy surface begins to vaporize, creating a glowing halo of gas and dust called a coma. The Sun's radiation pressure and solar wind push this material away from the comet, forming its iconic tail, which can stretch for millions of kilometers. These cosmic travelers are like celestial messengers, carrying with them pristine samples of the material that existed in the outer solar system billions of years ago. By studying their composition, scientists can learn about the conditions that existed during the solar system's infancy. But comets aren't just scientific curiosities. They've played a significant role in shaping Earth's history, delivering water and organic molecules to our planet during its early years. So, the next time you see a comet gracing our night sky, remember that you're witnessing a celestial time traveler, carrying with it secrets from the dawn of our solar system. All right, space enthusiasts, we've traversed the vast expanse of the universe, explored the birth and death of stars, and delved into the mysteries of our solar system. Now, let's turn our attention to humanity's own daring adventures beyond Earth's embrace, the era of space exploration. Imagine a time, not so long ago, when space travel was the stuff of science fiction, a distant dream confined to the pages of pulp novels and flickering black and white movie screens. Yet, in the blink of a cosmic eye, that dream became a reality, ushering in a new era of human ingenuity and exploration. The year was 1957, and the world watched in awe as Sputnik, a small, metal sphere no bigger than a beach ball, soared into orbit, becoming the first artificial satellite to circle our planet. This Soviet triumph Voyager spacecraft's grand tour of the outer solar system in the 1970s and 80s, robotic probes revealed a solar system far more diverse and dynamic than we ever imagined. We saw towering volcanoes on Mars, hinting at a once-active planet, and discovered evidence of ancient riverbeds, suggesting a watery past. We marveled at Jupiter's Great Red Spot, a storm system larger than Earth that has raged for centuries. We peered into the heart of Saturn's rings, revealing intricate structures and unexpected dynamics. And the discoveries continue to this day. The Curiosity rover, trundling across the Martian surface, has found evidence of organic molecules, the building blocks of life, further fueling the search for extraterrestrial life. The future of space exploration to Mars and beyond. As we look to the future of space exploration, the possibilities seem as limitless as the cosmos itself. With reusable rockets lowering the cost of space travel and private companies joining the fray, we're on the cusp of a new era of space exploration, one that promises to be even more ambitious and transformative than the space race. One of the most tantalizing goals on the horizon is a human mission to Mars, a journey that would push the limits of human endurance and technological prowess. It would be the ultimate test of our ability to live and work on another planet, a stepping stone to establishing a permanent human presence beyond Earth. But Mars is just the beginning. Beyond the red planet lie countless other destinations: the icy moons of Jupiter and Saturn, the asteroid belt with its mineral riches, and perhaps even the distant stars themselves. The future of space exploration is filled with challenges and uncertainties, but it's also a future brimming with potential and wonder. It's a future where humanity, driven by its innate curiosity and thirst for knowledge, will continue to reach for the stars, pushing the boundaries of what's possible and expanding our understanding of the universe and our place within it. Says Reflections on a Cosmic Journey. Well, folks, we've reached the end of our cosmic adventure, a journey that's taken us from the universe's fiery birth to humanity's first steps into the great cosmic ocean. We've explored galaxies, pondered the mysteries of black holes, and even tiptoed around the possibility of life beyond Earth. It's enough to make your head spin faster than a pulsar. Looking back, it's amazing to think how far we've come in our understanding of the universe. From those early skygazers who spun tales of celestial beings, to today's scientists who wield telescopes like cosmic detectives, our quest to unravel the cosmos's secrets has been a constant in human history. It's a quest driven by curiosity, by that innate human desire to understand our place in the grand scheme of things. We look up at the stars and ask those big, existential questions. How did it all begin? Are we alone? What's for dinner? Okay, maybe not that last one, but you get the idea. The universe, with its vastness and complexity, can feel overwhelming at times. But it's also incredibly humbling, a reminder that we're part of something much greater than ourselves. The interplay of science and mythology. Throughout our journey, we've explored the universe through two distinct lenses: science and Hindu mythology. Now, some might say these are incompatible, like trying to mix oil and water. But I disagree. You see, both science and mythology represent humanity's attempts to make sense of the cosmos, to find meaning and order in the face of the unknown. Science, with its rigorous observations, experiments, and theories, provides a framework for understanding the physical world. It's like the cosmic instruction manual, revealing the universe's inner workings with astonishing precision. Mythology, on the other hand, speaks to our hearts and imaginations. It's through myths that we've tried to explain the unexplainable, to connect with the cosmos on a deeper, more emotional level. Think of it like this: science gives us the what and the how of the universe, while mythology provides the why. always exploring. Our advancements in technology and science have opened doors that were once thought to be impenetrable. Space telescopes peer into the ancient past, capturing the light from stars that have long since extinguished. Robotic explorers traverse the surfaces of distant planets, sending back invaluable data that enriches our understanding of these alien worlds. But let us not forget, this journey is not just about the destination. It's about the stories we create along the way, the challenges we overcome, and the collective effort of humanity to reach for the stars. Each small step forward is a testament to our resilience, our ingenuity, and our shared dream of unlocking the universe's deepest secrets. So, as we continue to push the boundaries of what is possible, let us carry with us the spirit of exploration and the wonder that has always driven us to look beyond our horizons. The universe is vast, and our adventure is far from over. Please like, share, subscribe, and hit the bell icon for future notifications. Together, we will journey further than we ever imagined.